Hello, this is Elizabeth Brewington with Discover Brightside, where we discover new things. And today we are with one of my favorite authors and one of my favorite books on Earth Day. We've been doing Earth Day for 5 years, and we hope that you will enjoy this broadcast as much as you have enjoyed the previous ones. But without further ado, I know all of you know Bill Pekny, but I would like to read his bio for us once again. So, Bill Pekny holds a physics MS and BS degree from Georgia Tech and DePaul, plus a graduate study in physical meteorology and numerical analysis at the Florida State and the University of Utah, and a visiting scholar appointment at the Jinston Laboratory of Applied Physics at Stanford. Bill's career in science spans over 50 years in the U.S. Armed Forces and the aerospace industry. Highlights are Project Storm Fury, U.S. Navy, Hurricane Hunters, Applied Atmospheric Physics, and Meteorologists. And I could go on and on and on. And all you veterans that are on our broadcast, I think Bill has done almost all. He's been with the Navy, he's been with the Air Force, and he's been with the Army. So talk about bringing you guys all together. But what I really like in particular is about his book and the reason why he wrote this book, which is that everyone should gain and enjoy a greater understanding of our incredible Earth atmospheric system and its miraculous ability to nourish all life on this planet. And this is exactly the reason why we celebrate Earth Day every year, to give each of you a broader perspective on what's going on with our planet. So we celebrate our birthday, we celebrate anniversaries, but we need to celebrate Earth Day. So over to you, Bill. And Bill is a great guy. He's a dad. He's got grandkids, and he spends valuable time with us putting these slides together. And we've got books to give away. So thank you, Bill, for being our sponsor. And over to you with your slides.
Well, thank you very much, Elizabeth, for having me again this year. And let me share my screen now so we can just go through some slides and do some updates on what's going on in the air we breathe. So let's see. Okay, can you see that now?
Absolutely, yes.
Okay, so Elizabeth mentioned my book. It's Tale of Two Climates, One Real, One Imaginary, a deeper look, an easy to read book for young adults and up. And so that's what I'm about. Like she said, I spent 22 years on active duty with the Army, but with a hazardous duty attachment to the Navy with the Hurricane Hunters, and then another 20 years as a civil servant working with the Air Force on atmospheric projects. So Earth Day today, for me, it's about demystifying environmental science in general and categories of environmental science that we all most often hear about now are the big three here: pollution, energy, and temperature. And that's what I'm going to talk about. But let me start by with an upfront disclaimer here that near the breaking point on book sales, and that was never my wife Nancy and I's objective to make money on this. It was just to get the word out, and we're nearing a break-even point. But I'm not beholden to anyone other than those book sales. I'm not getting any grants from anybody. I'm not getting any donations from anybody. And on the other side, I'm not paying anyone either to advertise for me. Not big oil, not politicians, not anyone other than the gas that goes in my car and the heat in my home. And so just wanted you to be aware of that there's nothing in this for me other than the love of science and getting the word out uh, the both so you can hear both sides of the story and decide for yourself what you would like to believe. Um, I was brought up back in the 60s on the time-honored scientific method, and so that's how I operate. And I don't operate on consensus, which seems to be some of the way things go wrong these days in science. As the noted author Michael Crichton said, as you can see there, watch out. All too often these days, we're about money, power, and control. And so you have to keep that in mind when you're deciding what you believe when you hear scientists talking. So let me start first and talk about temperature for a few minutes. This is this chart on the x-axis is years from 2000 through today, and the y-axis is surface temperature anomaly. That's how much temperature is changing. And these are monthly, the data points that go into this chart are monthly summaries of weather events. And as you can see, there's a very zigzag nature to it all. And what's really talked about most, though, these days is not the weather events themselves, but the climate, the trend in weather. And by climate, the official definition is a 30-year trend in the temperature, for example, over a large area, be it a neighborhood, a city, our country, or the globe. And so you've got to recognize the difference, the zigzag nature. People that look at the high points of temperature and say that it's warming. Well, it's true, but you've got to look at the overall big picture. And that's what the book is about, is the big picture aspect, because I could just very well look at the low points in temperature as well. But again, we're looking at the big picture here. There's more to, so what determines temperature? There's several different things. Think about, for starters, though, that just this this planet we live on, in its spin cycle every 24 hours, what's happening there? The Earth is spinning, and as it does, it's dragging the water, which is almost 71% of the Earth's surface. It's dragging the water along with it as it spins, creating the ocean currents, the many different ocean currents that we have. And then also it's dragging the air along with it too, the jet stream, the air currents that we experience. So that's one factor that goes into this climate story. Besides this part of planetary motion, there's also gravity, and these forces also affect the temperature and the climate that we experience, and it's just a very complicated thing that we don't know everything. We don't know everything yet, but these are the major forces. For example, in here, the Earth's tilt changes from year to year, and the Earth also wobbles, and the Earth rotates around the sun. And let me make sure you understand, this isn't to scale, it's just for teaching purposes. So the Earth orbits the sun every 365 days, and that orbit is a little bit eccentric. It's not always quite circular, and that affects temperature and climate. So what we really need to do is look at a really big picture here to understand our solar system and to be able to evaluate it properly and not just isolated pieces of it, which I call cherry picking. And so the climate in general and temperature in particular, the control knobs that, as I see it, that are the major drivers of our temperature and climate are, of course, the sun, our source of energy, water, as I mentioned earlier, that covers 71% of the Earth's surface, and that's a big player here. And then gravity and inertia that I talked about on the other side. So advocates of extremism and climate, that the Earth is warming badly, or the Earth is about to burst into flame, is the other side of the story that I'm trying to help bring the more total picture to. So these really big things, the sun, water, and planetary motion, and not we humans or our SUVs are in control here. It's Mother Nature more than anything else. So let me talk now just a minute about the carbon family, because that's in the news a lot later when we talk about net zero and removing carbon from the atmosphere. It comes in three essential forms: elemental carbon, which has the chemistry symbol C, and which we know as soot. Carbon monoxide, a very, very deadly gas that's in the air, which adds just an oxygen atom to carbon as becomes a molecule that can kill us in a heartbeat if we're running our car or a power generator in a closed space or anything like that. And so these first two are both pollutants, which we like to get rid of and have by over a factor of 10 since I was a kid in school back in the 50s. And then there's carbon dioxide, or CO2 as we call it, with the extra oxygen atom, which is quite the opposite of carbon monoxide. And carbon dioxide, as I hope you'll understand as we go along through this, is the gas of life. Without it, life doesn't exist. It is not a pollutant. So let's look for a minute at what's in the air we breathe. It's mostly, as you can see here, percentage-wise over here on the right, and then in parts per million, which are the way you see it in the media and expressed. And it's mostly, as you can see, over 97% is nitrogen and oxygen, and down here is, in this fifth row, is carbon dioxide, which is 0.04%. And that's not 4%, that's 0.04%, as well as trace gases and things like stratospheric ozone, which is good up high because it protects, it filters out a lot of the ultraviolet that would be bad for us, or worse than getting the sunburn is now. So those are the clean gases in our air. And red here are the bad gases, as I mentioned before, carbon monoxide. Methane's not really, it's perceived as a pollutant, but it's really something that's very useful to us, as a lot of these are. Nitrogen oxides, for example, nitrogen dioxide is laughing gas, or what dentists give sometimes. Sulfur oxides are bad. Ozone nearby is truly a pollutant, and it goes on like these. So the green is the good gases, and the red is the bad gases in the air we breathe. And you can see here just how much smaller they are, or how they've gotten lower over the years. And then also in the air we breathe is some particulate pollutants, lead, which is pretty heavy, so we don't see that in the air nearly as much as the other things. But then there's this particulate matter we call PM 2.5, which is, for example, an example of that is smoke from wildfires. And then particulate matter that's 10 microns and less in in diameter, or PM10, is things like dust and soot from a lot of diesel auto trucks and the like. So those are the main things that are in the air that we breathe. So now let me focus on carbon dioxide for a little while here. It's true, carbon dioxide is growing in the atmosphere, and you can see it here. It's fairly straight over the most recent past, and the zigzag nature of this is just the seasons, lower carbon dioxide in the summer when the trees are and the plants are sucking it up, and more in the winters. And that's that zigzag nature of this curve here that you see. Thanks to carbon dioxide, our Earth is greening. This picture that I'm showing you here is a satellite photography. It's a combined image that goes over about 30 years and shows the change in greenness of our planet over the last 30 years. And why is this happening? Our Earth is greening, although not everywhere. As you can see here, this is the Sahara Desert region of Northern Africa. And but overall, our Earth is greening. And a lot of that is due to increased CO2 as well as rising temperature in our air. The other thing about CO2, though, is that it's a diminishing returns kind of thing. It's now saturated is the term that we use. And by that, I mean that no matter how much more CO2 goes into the air, any warming from it is almost zero. It's negligible in comparison to everything else. So the point here is that CO2 being saturated in the air, what we hear a lot about is that CO2, because it's an exhaust gas from our tailpipes and our smokestacks, it comes out of our tailpipes along with water vapor and the other pollutants, but it is not a pollutant. And as I'm going to show you in some future slides here, is that we need more of it in our air, not less. So let's talk about the greenhouse effect for a minute. As you can see, this is graphic just shows first of all the sunlight, the visible sunlight that we get every day as the Earth spins about its axis, and at night that warmth. So the sunlight warms during the day our ocean and our land and our air, and then at night that absorbed energy is re-radiated back out to outer space. We call that terrestrial radiation. When the sunlight exceeds the terrestrial out to space at night, that means the Earth is warming. When the at night energy, the terrestrial, is greater than this incoming visible light from the sun, that's when we're cooling, typically at night. But then when we add greenhouse gases into the equation here, they tend to absorb some of that outbound terrestrial radiation and point it back at Earth. And so that energy that's re-emitted back down to the Earth and the rest goes to outer space is the effect of the greenhouse gases as a blanket, as I like to refer to it as. What I'd like to show you here now is a little bit more about that greenhouse effect. This is a theoretical equation, and you got to be careful when you're listening to people talk about science and physics and meteorology and climate in particular, that this is an equation. This is not a measurement. It goes back to the 1850s to a scientist by the name of Schwarzschild. And this is what The x-axis is energy flux at the top of the atmosphere, looking down towards Earth at what's coming back up at this outbound terrestrial energy at night. It's mostly here in the infrared and much less as we go to the visible in the ultraviolet. This equation is based on no, or model is based on no clouds, a clear sky, and no greenhouse gases. And if this were the case, this theoretical model would result in a temperature of the Earth of almost 0 degrees Fahrenheit, well below freezing. And Earth would be a frozen ice ball perpetually if this were the case, if there were nothing else. So when we add the greenhouse gases in, the area under that black curve reduces. The area under the green is how much energy is getting back out to outer space at night, a lesser amount than if there weren't any greenhouse gases. So that's why people like to say the greenhouse gases warm the Earth. Well, they do, but only a little bit, as you can see here. So these are actual measurements, the green here, of energy versus wavelength, wave number. And this represents with no carbon dioxide in the air. Now, if we add where our carbon dioxide is right now at 420 parts per million, this even a lesser amount gets back to outer space. As you can see here, if I toggle back and forth, no CO2, CO2 at our current levels. And what that results in is an average Earth temperature globally of about 59 degrees Fahrenheit. Now, what if we double? This is what people like to talk about a lot recently. What if we double the CO2 that's in the atmosphere? How does it change? Well, as you can see, it doesn't change very much at all. And here's an overlay that shows both the red versus the blue here. So if we double the amount of CO2 in the air, the energy escaping to outer space or the warmth of the what doesn't escape the Earth's temperature is negligibly different. Another perspective that's always helpful for me is to look at carbon dioxide over a very long term. Now on the x-axis instead of just 20 or 30 years. And let me back up to one other thing here. And that is that these lines here, this is a theoretical line, a model. These are actual empirical measurements, observations, recordings. And so that's real data, real empirical evidence. Looking backwards in time, over here on the lower right, we start with today at 0, going back to 160 million years before now, and looking at the atmospheric levels. 160 million years ago, carbon dioxide in the air was much, much higher than it is today. And if anything, we're closer, nearing a famine line. We're closer to the minimum than even the optimum for our plants. So relatively speaking, we're much lower today, although, as I said before, today the carbon dioxide is going up a little bit. So now let's talk about what you hear in the news a lot lately. Talk about net zero carbon. What they really mean of those 3 items that I mentioned earlier is net zero carbon dioxide. The alarmists, the sky is falling advocates are saying that carbon dioxide is warming our air, and as quoted here, it's the most serious existential threat to humanity that we've seen, all because of CO2 preserving or warmth via the blanket effect. They view it as a threat. And why does this happen? Why do they do this? Well, it's typically about money, power, and control. Follow the money, and you'll see what's going on here. So that's what's supposedly in the budget. What did we call it? The Inflation Reduction Act. There's trillions of dollars out there for helping us get to net zero carbon dioxide in the air. But the fact of the matter is, as I've pointed out earlier, is via real data, real measurements, is that CO2 is not a pollutant at all. And its big brother, water vapor, prevent our planet from being perpetually frozen. CO2 is also an airborne fertilizer, as I showed you in that satellite picture. And as we know from photosynthesis, it's a food and oxygen generator. And as I mentioned earlier, it's saturated in the air. So the bottom line of all of this is that they're trying to steer trillions of dollars of money to remove carbon dioxide from the air via a new technology that's unproven called carbon capture and sequestration, or CCS. And they're putting trillions of dollars of taxpayer money into this, where I think we should be doing other things for our people to feed the hungry and the like. And my thought is CO2 is free, and we need more of it up there than less, as I've been showing you previously. So the bottom line, as far as greenhouse gases go, is that, as I mentioned earlier, it's greening the earth, CO2 is. It doesn't warm the earth, it just acts as a blanket and prevents excessive cooling. And in summary, we need to be good stewards of our planet. We need to keep it clean, whether it's the ground, the air, or the water. We need all forms of energy, but they need to be reliable, abundant, affordable, dispatchable. And when I say all forms of energy, I'm talking about fossil fuels, which we have an abundance of, nuclear energy for power generation, wind and solar, which aren't reliable right now because when the wind doesn't blow and the sun doesn't shine, it's not as reliable as the other forms of energy. And the fact of the matter is our weather and our climate, it's always changing. There's nothing new going on here. And the book discusses that. There's 13 chapters where that goes into that in excruciating detail with excruciating evidence to support it. And so what I really want here is, and what I worry about is what's being taught in school, especially our impressionable youth, to be taught how to think, not what to think, and know that they don't need to be afraid of climate change, or as I prefer to call it, global warming at present, global cooling in the past, and probably in the future. Study it, respect it, adapt it, and most important of all, enjoy this nutritious and ever-changing weather and climate that we have. So to finish up, this is a billboard that's been here in the Salt Lake City area for the last 6 months. It ended in March, telling the story that in spite of the fear-mongering that's going on, that we're about to burst into flames, there is no climate crisis. Everything that's happening is natural and normal. And yes, our temperature is growing up slightly and beneficially if you look at it in the long stretch, but it is beneficial. It's not a crisis. And no matter how much more CO2 we put into the air, it's the warming from it's negligible. So let's not waste trillions of dollars in this thing they're calling net zero. So that's it. If you want to get a book, if you want to get it directly from me, just shoot me a text or a call or an email. And I invite you to go look at the website. There's a lot of examples and good stuff on there, as well as if you get it from Amazon, you can get it for the price listed there. And so that's it in a nutshell. And I'm done here and open to questions. And Elizabeth, I'm going to stop sharing now. So there we have it. That is my outlook, trying to tell the other side of the story.
Well, thank you for your description. I appreciate that. You know, you've outlined in a very careful and particular way the importance of our understanding, especially as it relates to global warming, but also the CO2 levels. You describe for us that we don't have to be so fearful, and but we do have to be careful in how we manage and are particular about helping Earth particularize our comfort zones. I appreciate that. I guess my concern is how do we, you know, in our own environments, you know, position ourselves, you know, so that you know, we're moving along. I mean, the Earth is going to take care of the Earth. It's been doing that for billions of years, you know. But I mean, you know, how do we manage our lives, you know, according to what the Earth is doing? You know, big important information. Um, uh, eh, I guess. Oh man, you and thank you for these slides. These slides give a more update perspective about what we need to be doing and how we do these kind of things for the generalists. I guess I don't consider myself to be a scientist, but more or less a
Yes.
generalist. You know.
But we have some guests on the show, and this broadcast will go live today at maybe 2 or 3 today on Facebook. Hi, Linda. Any questions? And I think Ray is on as well. Roy, if you'd like to show your video, Roy
That's
Nor.
my brother-in-law, Roy.
That's your brother-in-law. All right,
Yes.
all right. So,
My
Linda, would
best
you like
friends.
to ask a question?
Well, I can't hear you.
Yeah.
I was muted.
There
I'm
we go.
always curious about the water.
Okay.
Does there's spring distilled, purified, regular tap? I mean, is with the spring and the purified, is there a big difference in the water? What should we be drinking?
A biologist, I'm not, but what I do know is that the purified water is the best water to drink. If bottled water from the springs, the natural water that we get here in Utah, for example, where it's usually very dry there, the water that we get from our underground, from our springs, is got a lot of other stuff in it, but most of them good. Nutrients, I can't rattle them off
Yeah, that's
my
okay.
head, but so natural water coming from the ground that's been at one time or another above the ground is filtered by the ground itself, and in that carbon cycle or that water cycle, and now coming back up to us, is usually pretty good. It's always pretty good. They monitor it closely. Taste wise, though, I prefer the natural water, I guess. But we have a very across the whole United States, whether it's out here in the Intermountain West or back by you in North Carolina, near the Atlantic Ocean, water is monitored carefully. for the bad things that go into it. So I wouldn't worry about drinking spring-fed water at all. I do it all the time.
Okay, okay. And one thing for sure, the earth is really changing.
Yes, it is.
The earth itself is really, there's a lot going on.
Yeah. Well, my question before Claire adjusted me are the storms, the level of storms. And I could surely see that the intensity of the storms have gotten more severe, and especially during seasonal months and during the winter. I don't know. I mean, hurricane season, you know, any advice?
Yes,
Mhm.
yes. As a matter of fact, um, this show is originating from North Carolina along the Atlantic coast where you get hurricanes. My son in Orlando, Florida, I think gets even more. But as far as hurricane intensity goes, what you've got to think about looking back in time, let's go back to the 1990s, for example. Um, well, let's go back a little bit further to the 1960s. And while it seems like they're getting worse, as you say eloquently, Elton, they're actually not, because we're just seeing more of them now, thanks to our ability with satellites to see the whole Earth and not just what's going on the Atlantic coast. We can see that there's a whole lot of hurricanes out there that don't ever make it to land. And so, and even on the eastern coast right now, um, they're zigzagging up and down from year to year of late. Some are worse, some are better. Last year, for example, hurricane season along the Gulf and Atlantic coast, we had a rather mild hurricane season. And I've got a chart I can show you. But this year, 2024, they're anticipating a stronger than normal hurricane season all along the Atlantic and the Gulf and the Caribbean. So it zigzags. But when you look at it over a long, long period of time, and what I'm saying here since satellites have been around, is that if I can share my screen one more time and just go to a quick slide, a couple of quick backup slides I had to address your question uh,
You
with
did
some.
change slots.
No, he can share it. Yeah.
Yeah, I can do it. Okay, are you back? Can you see
Yes.
my slide?
Yeah.
Okay, so let me shift to, bear with me just a second. Yeah, okay, so here's all hurricanes. This is now from the Colorado State University. There again is the blue line is what carbon dioxide is doing. And the red line is all hurricanes that are seen by satellites, whether they hit land or not. And their energy, accumulated cyclone energy, is what this y-axis is. And this is going back since 1960 to the currently, and this is updated as of last year, 2023. So yeah, they were worse here, Elton, back in this time period here. And the hurricanes were worse here. And this is in terms of energy that they deposit on your head in the forms of rain and wind and all. And this is from all the hurricanes, whether it's in the Caribbean or the Atlantic or the Gulf Coast over the last, 60 years now. And so, yeah, it's true what you say. Probably the last 10 years, a lot of these peaks and storms have been along the Atlantic coast where you all live. But when you look at everything all the hurricanes that are out there, many of which never hit land, uh, this is the situation. Does that help
Yeah.
put a little perspective?
Yeah, yeah, yeah. You know, you make me understand as I remember. As a matter of fact, it was the War of 1812 which caused the British to be pushed back so that they couldn't, they had already overcome and beaten America to take over. But the War of 1812, a huge storm took over, and the troops from Britain just ran, and which allowed America to be America. And so it was an amazing story. I said America was overcome by a storm. America is America because of a storm.
Yeah.
Uh, is a,
Couple other
uh-huh.
couple other things in this same vein of, I'm sorry, did I cut you off, Elton?
No,
I
no, no,
didn't.
go ahead, go ahead, go ahead, go ahead.
Let me show you a couple other things too that uh, are some misperceptions that happen fairly frequently. Um, tornadoes.
Uh-huh.
They're significantly down, and that makes sense with our slightly warming temperatures. Again, I'm showing, my apologies, this shows CO2 on here again. I seem to be stuck on CO2 a lot. Killer tornadoes. We have much better warning than we used to have in the 60s, 70s, 80s even. And they're not, and as our climate warms slightly, we would expect fewer tornadoes because tornadoes are caused by when cold and hot air masses spring more moist air coming up from the south and still the winter cold air masses. And when they cross each other, you get this turbulent motion. And as it warms up, those temperature gradients, the difference between hot and cold ease a bit, then you would expect fewer tornadoes. And that's in fact what's happening. Wildfires. What we seem to focus on these days is the wildfires, especially here in the West, where California, Oregon, Utah, Nevada, Arizona, Washington State, and the like. Again, there's that same picture of the carbon dioxide. But when you look back toward the Dust Bowl era, and the y-axis that I'm showing here is the number of acres burned. That's the best metric for wildfires. You can also look at the number of wildfires, but the ones from back in the Dust Bowl era were much more, 50 million acres burned versus now we're in the the 8 to 10 million acres burned a year here. And there are some alarmists that choose to only look at this and not the whole big picture. And that's the sort of thing in the book that I'm trying to do is show that side of it as well. There's one other thing that I wanted to show you if I can find it. Oh yeah, heat waves, same story. Heat waves, especially out here in the West, are fairly consistent, except back here again in the Dust Bowl era, where we had this significant spike. But things are flat. The trends, when you look over long periods of time, are fairly flat.
But
And
this would
so now,
imply that during the drought that you guys went through in the West. I mean,
yeah,
you had so much rain in the last 4 or 5 years now. It sounds like the drought is no more concern because I don't know how it stands with the Colorado River and that kind of thing, and whether it balanced out and what that means.
yeah, I'm told that the Colorado River is still struggling a bit. Everything's getting better out here the last few years, but even Lake Powell and some of those um, dammed lakes in southern Utah and California
Mhm.
have grown. Like Lake Powell, I'm told, uh, gained 44 feet in the last year, but it's still fairly low. It
Mhm.
has to
Mhm.
get back to the way it has been in years gone by. So yeah, but we all know that here in the Intermountain West. Utah in particular is an arid country. We've known that and we deal with it, and we love it when we get all the extra snow for the skiers and the rain for as long as it all doesn't come down at once and flood.
Yeah.
So you have given us a perspective that lets us know it's a big picture. Keep our eyes on the big picture, not be concerned by the short turns in weather, and ride through the weather, and it will balance out, if I understand you.
Yes.
Mm-hmm,
But always be critical thinkers at the same time.
mm-hmm.
Dig into, don't just listen to anything that everybody says. I mean, my whole philosophy on this book is I just want to present a side of the story for people to decide for themselves what to believe and what not to believe. I early at the start, I tried to convince you that I'm not in this for the money. But there are a lot of people that are, and one of my themes is if you want to understand what's going on, follow the money.
Yeah.
Well,
And I think the big thing, even for us, is not about the money, but it's about educating people about Earth Day and the environment. And you're absolutely right, because people don't want to do planet and environment topics, because money is harder to come by, but we need to do it because it's important that we are up to speed with what's going on. So I think this was excellent. It was a thorough, the slides were just amazing, and the wealth of information that you've shared. We will be going live on Facebook and Instagram with this today, so it's going to go all through Earth Day as well. And I probably will have some more interviews and programming going on this week because of the thunderstorm today. We've had a little setback, but we would really love to work more with you, Bill. And I know your schedule is very tight, so I'm just going to invite you, and when you can jump in, please do. We will make the book available. I think Linda's on today, so she gets her book, and we will make the book available to people who are interested in this subject matter. So if you're watching us on Facebook or Instagram, and if you catch this live, write us a comment, tell us what you think. And remember, you celebrate your birthday, you celebrate an anniversary, you need to celebrate Earth Day. It's probably very powerful to do that. So once again, we're in our 5th year of doing this, and each year it's been different. We've had the Japanese consulate, we've had the German consulate, we've had a lot of people on our channel talking about. Yeah, Linda, you want to say something? Okay. All right. So with that, I just want everybody to be aware that the book is available to you, and